Hello, my name's George Nicholson. Here at Wigton, what we're trying to do is restore 1960s computer equipment and 1960s training equipment. This bit of kit here is actually 1970s, on the edge of 60s and 70s. Today, this is the BBC Microbit. This is the BBC Microbit, and what it does, it's a complete computer. Absolutely a complete computer. And this was given to every 11-year-old in schools in Britain, so that they could learn to program, so they'd learn the skills for the next generation of programmers. You probably can't see, but in the corner here is a little bit of black plastic. In that little bit of black plastic is the processor, the heart of the computer. It's so small, we call them microprocessors now. Now, if that microprocessor was to go faulty, there's nothing we could do. You can't take the plastic top off and get a look inside. Wouldn't happen, never happen. It's just far, far too small, far, far too delicate. What you would do, in fact, is if the processor went faulty, you would throw it away. It'd be a bit of a pain, but it's £15. You'd survive and buy another one. In the 1960s, it wasn't that clear cut. Computers were made up of these things, hundreds and hundreds of these things. The processor I'm talking about would be made up of these boards. You might have dozens and dozens of these boards making the processor up. So, rather than this little small thing here, you'd have racks of these things making up this processor. And rather than costing £15, the processor, in modern money, would be £100,000. You wouldn't throw that away if the processor stopped working. Now, what you would do is you'd have engineers that knew how processors worked, getting into the board, pulling these boards out, fixing the ones that went faulty, and bringing the system back online. How would you train those engineers? You train them with things like this. This is Digital Equipment Corporation's computer training lab. And what it does, it's got all the basic circuits you would need to explain how these individual boards are working. And in fact, more than that, how a series of those boards put together would work. So young engineers would use the computer lab workbook. In this, they would find out all about the basic computer circuits, the basic processor circuits. They would learn how a computer went together from scratch, from boards all the way up to big things filling rooms. And then what this book would show them is basic computer circuits that they could understand, and then use that knowledge to go on and to fix the computers. What I've got here is one of those basic circuits. It's in the book here at page 67. You might not be able to see it, but it's that one there at the bottom of the page where my fingers are. And it's a modified asynchronous binary counter. And basically what it does, it counts in binary. And if you don't do binary at school, I'll work it through for you. But basically, that's 4, 5, 6, 7, 8, 9, 10, 11. It gets boring. It counts up in binary from 0 to 15 and then resets. And it's one of the basic circuits these engineers will need to know about. And these circuits, like I say, would be in these big wardrobe-sized computers. And those engineers would need to know how those worked in order to fix them. These days, only very specialised engineers would need to know how to put together a microprocessor. It's not even a skill you would really need to teach. It's very specialised. Maybe a few dozen in Britain could do it. The only other people that would really need to know how a processor goes together is us in Wigton, because we're trying to fix those 1960s computers.